Hello students, in this video we have assignment 6.6. Two questions will take up in this video, and in next one we'll take another two. The questions are 4 units of mutual inductance. We already have seen it, we'll revise it, and then one very important topic, reciprocity theorem. We'll take up this two, we'll take up in this video. And then AC generator, its construction and principle, working. We'll take up in next video. Okay, so in this video we have mainly reciprocity theorem. Uh, Let us start with it. Consider a condition. Okay, before that, let me quickly revise 4 units of mutual inductance. So in case of mutual inductance, the formula are M is equal to phi by I and M is equal to epsilon by di by dt. Okay, this is not enough. I know we need to mention suffix. So if you are talking about M21, you are talking about mutual inductance of 2 due to 1. So you will have phi 2 I1. Here also if it is 2 1, epsilon 2 di1. Okay, and what if you have M12, then suffix will also be swapped correspondingly. So consider you have first coil connected with variable battery, let it be first coil, and second coil placed near to the first one connected with galvanometer. So when you allow current to pass through the first one, you have flux linked with the second one, and when current passing through the first one changes, flux linked with the second changes, and from that we have this formula of mutual induction inductance, and that is all what we saw last time. Now, consider that you have a coil which is placed in such a way that another coil of same length is placed around it in such a way that it is enclosing it, and the two are placed coaxial. Let us label this one as 2 and the inner one as 1. Okay, so we'll have parameters like N1, A1, L1. We will have parameters like N2, A2, L2. So whenever you have N, it is number of turns. If it is N1, number of turns of first one. If it is N2, number of turns of second coil. Area, A1 is area of first coil, A2 is area of second coil. L we have taken to be same, so we'll take L1 is equal to L2 is equal to L. Okay, that is the length of the coil. We are considering it to be same. So now, if I have current passing through the first coil, suppose I am allowing current to pass through first coil. We have two cases here. In first case, we will consider current through coil 1. Next time we will take current passing through coil 2. So when current is passing through coil 1, you will have flux produced here, isn't it? And then what should I say about flux linked with second coil? It is proportional to current 1. Okay. And how do I find out flux? We know that flux is B into A. So number of turns of second coil, magnetic field of first one, because first coil is carrying current I1, and area of second coil, okay, is equal to M21 I1. Now here I am making mistake. It should not be A2. Why it should not be A2? The reason is, even though A2 is this much, this is A2, but field lines are passing through this small area. And so the correct equation would be N2 B1 A1 is equal to M21 I1. Okay. What is B1? B1 is mu 0 Ni. B is mu 0 Ni, so B1 is mu 0 N1 I1, and B1 can be written as mu 0 N1 by L, number of turns per unit length, into I1. So substituting it here, what do I get? N2 is mu 0 N1 by L I1 A1 M21 I1. And what if I take M21 subject of formula? We'll have mu 0 N1 and 2 A1 by L. Let us check second possibility. What if we pass current through the bigger one? Now, when you are passing current through this coil, second coil, suppose if it is I2, then flux linked with the first coil is this much. So at that time also area will be of first coil. So for second coil, when current is passing through second coil, flux is linked with first one. So I2, flux is NBA is equal to M I2. Which suffix I should be using? I am talking about flux with first one. Sorry. Okay, so number of turns of first, area of first, but magnetic field of second coil. And then N2 B2 A1 is M12. I am talking about mutual inductance of 1 due to current passing through 2 I2. Okay, what is B2? B2 is mu 0 Ni, which N, which I, so N2 I2, or else mu 0 capital N2 by L I2. Substituting it here, we get N2 to be equal to, sorry, N2 into mu 0 N1, sorry, N2 mu 0 N1, I think I'm making a mistake, sorry, N1 should be here, so N1 mu 0 N2 by L A1 is equal to M12 I2. Make M12 subject of formula and you will get mu 0 N1 N2 A1 by L. Now look at this two. Same. And that shows that mutual inductance of second coil due to first, or mutual inductance of first due to second, both are same. So M12 is equal to M21. This fact is called reciprocity theorem. And if you remember, we had similar formula for self-inductance, which was mu 0 N square A by L. Okay, instead of N square, N square, now we have N1, N2. So that is all about mutual inductance and reciprocity theorem. And we end for now. In next video, we will talk about AC generator. Thank you.